In this session, we'll specify a set of parameters which define a template file that will allow us to control the way drawings appear when they're plotted. After choosing the Start from Scratch option, we'll select the default settings of English and then click on the OK button. We'll now select the pull-down option Tools, followed by selecting the Options selection. Now we'll click on the Plotting tab of the Options window. The settings that we'll establish require that we click the Plot Styles button. And then, in the default plot style table, we'll select acad.stb, followed by clicking on the OK button. In order to have our new settings take effect, we need to close this file and start a new one. We'll do this by clicking on the X in the Drawing 1 window and then click on the No button. Now we'll click on the New icon. And then after choosing the Start from Scratch option, we'll select the default settings of English. We'll now continue to establish settings by selecting the pull-down options Tools, followed by selecting the Drafting Settings option. Now we'll set the grid spacing to 1.0 and the snap spacing to 0.5 in both the X and Y directions, and then click on the OK button. In the status bar, we'll now click on the Snap, Grid, and Model buttons in order to turn them on. We'll now click on the Layers icon and then create the series of new layers that are shown here. In order to define the sheet of paper that we'll be creating our hard copy on, we'll click on the Layout 1 tab at the bottom of the window. We'll first select the plot device that we wish to use. Then we'll make sure that the paper size is set to letter size and the orientation is set to landscape, and then click on the OK button. We'll now set the title block layer as the current layer, and then draw a rectangle that is 10 1/4 inches by 7 3/4 inches. We'll now add the other fields shown here and then use the text command to add the annotation. Now we'll click on the Model tab at the bottom of the drawing window to switch back to model space, and then set the current layer to construction lines. The final step is to save the file as a template file. We'll make sure that the file type is set to Template File, and then name the file ACAD A Title Block. AutoCAD now gives us a chance to add a description, which we'll do now. And finally, we'll exit. In this session, we'll create a drawing of the Geneva cam mechanism as shown here. After starting AutoCAD, we'll select the Use a Template option and then select the template file ACAD A Title that we created in the previous session. We'll now select the Layers icon and then set the construction layer as the current layer. Our first step will be to draw construction lines, so we'll click on the construction line icon now. We'll now key in the coordinates 5, 4.5 to define the first point on the construction line. Then we'll move the crosshairs directly above this point in order to draw a vertical line. Now we'll reposition the crosshairs as shown here in order to draw a horizontal line. We'll draw one more construction line that is at a 30-degree angle by keying in @2, then the less than sign, followed by the angle 30. And now we'll right-click to end the construction line command. We'll now draw the first of 5 circles by selecting the circle icon and then identifying the intersection of the construction lines as the center of the circle, and finally keying in 0.75 as the radius of the circle. Now we'll repeat the process to draw the other 4 circles shown here. We'll now move to the status bar area and make sure that the Grid, Object Snap Tracking, and Line Weight are all turned on. Prior to drawing any lines or circles that actually represent the Geneva cam, we'll click on the Layer control box and set Object Lines as the current layer. Now we'll click on the circle icon and then draw a circle that lies on top of the 4-inch radius. We'll repeat the circle command to now draw the circle shown here that has a radius of 1.5. And then draw one more circle as shown here that has a radius of 0.25. We'll now use the offset command with a distance of 0.25 and then select the inclined construction line shown here. We'll locate and then left-click the mouse below the selected construction line and then click the right mouse button to stop the process. Now we'll use the zoom window option to zoom in on the area shown here. The next step is to select the line icon and draw a line between the two intersection points shown here. We'll now use the trim and erase commands to remove portions of the circles as shown here. The next step is to use the mirror command and then select the objects that we have created on the object line layer. After right-clicking the mouse to accept the selected objects, we'll left-click on two intersection points of the horizontal line. We'll now right-click the mouse and select the Enter option to accept the default answer of not deleting the source objects. Our next step is to select the Array command in order to make copies of our existing objects using the Polar option. We'll now use the selection window to select the objects. And now, after right-clicking to accept the selected objects, the pop-up window shown here is displayed. We'll make sure that the center point is defined to be x equals 5, y equals 4.5, and the total number of items is set to 6. Now we'll click on the OK button to create the other copies of our array. The last step in completing the drawing is to add a keyway and then place the dimensions on the part as shown here. In this session, we'll combine the title block that we created in the first session with the drawing of the Geneva cam and then produce a plot of the results. We'll start by clicking on the Layout 1 tab to switch to the two-dimensional paper space that contains the title block. Now we'll select the pull-down menus Views, Viewport, and then One Viewport. In the status bar area, we'll now turn off the Object Snap option. We'll now specify a viewport inside the title block as shown here. In order to specify the properties of the viewport, we'll first select it and then click on the Properties icon. We'll now left-click on the Standard Scale box and then scroll down the list of available standard scales. We'll select the 1:2 entry, which will set our plotting scale to half scale. Now we'll click on the X in the upper right corner in order to close the Properties dialog box. Our next step is to hide the viewport border so that it will not be plotted. We'll do this by first moving the pre-selected border to the Layer Viewport by clicking on the Layer Control box and then clicking on the layer named Viewport. Since we have now moved the border to the Layer Viewport, we'll now turn off the display of this layer by clicking on the light bulb icon. The last step prior to plotting is to adjust the scale of our dimensions. We'll do this by right-clicking on the standard toolbar and then selecting the Dimension option. We'll now click on the Dimension Style icon and then select Modify. Now, after clicking on the Fit tab, we'll click the radio button next to Scale Dimensions to Layout and then click on the OK and Close buttons. We'll now click on the Dimension Update icon and then select the radius dimension shown here. Now we'll right-click the mouse in order to update the selected dimension. We'll now repeat this process in order to update each of the dimensions. To actually produce a plot of our drawing, we'll start by clicking on the plot icon. Now we'll make sure that the proper plot device is specified and the plot area is set to Layout. The plot scale should be set to 1:1 and the plot options Plot with Plot Styles and Plot Paper Space Last should both be checked. Finally, we'll click on OK to produce a plot.